Hi, I hope everyone had a good spring break. I assume you're aware that we're going to be doing things a little differently from the rest of the semester. We'll have to see how this goes with working with the hardware here. I hope everyone has their NetBurner development kit wherever you are and have installed um, the NetBurner software. What I'm going to be doing is actually, recording the lectures so that you can watch them at any time. On this first lecture period, on Thursday, March 19th, I expect to have, Zoom meeting at 10 o'clock. Class normally starts at 9:30, so that'll give you a half an hour to watch this video if you haven't already, and then we can start the Zoom meeting at 10 o'clock, where I'd like to discuss any problems that anyone has had installing the software or getting applications to run on your NetBurner board. If you left your NetBurner board here in Cook Center, please contact either myself or Jeff as soon as possible so that we can get that to you so that you can start working, doing your work on at wherever you're located. Let's see, let me switch over to the lecture mode here. Today I really just wanted to give you an overview of the NetBurner board, talk a little bit about the board. We'll essentially repeat what we went through last time and getting started with the board. So hopefully I'm not going to give it an in-class exercise today or a new assignment. You'll get that next Tuesday. You'll get your first multitasking assignment with the NetBurner next Tuesday, using the new operating system that we're going to use. So again, just giving you a little more time to get everything set up on your personal developer environment. So the NetBurner module that we're using is based on a 32-bit Motorola Coldfire processor. The processor runs at 148 megahertz with 64 kilobytes of internal static RAM, 8 kilobytes cache, has an embedded Ethernet controller, has 3 serial ports. You've got connectors on the motherboard for 2 of them, 4 32-bit timers, 4 16-bit programmable interrupt timers, 4 DMA channels, 47 digital I/O, watchdog timer, and a lot more. Those are just some of the features. Comes with a number of good support libraries for getting started with internet networking, and that will be some of the focus here after we cover the basics of the operating system. So again, we're transitioning from a virtual machine to actually using real hardware here, so that you can actually control real devices. The NetBurner module board, which is so all of that was embedded in the processor itself. The module board, which sits on top of the motherboard, adds 2 megabytes of SD RAM, 512 kilobytes of flash, 2 50-pin connectors, and then there's the Ethernet jack, the RJ45 Ethernet jack. And then the carrier board or motherboard provides 2 serial connectors, RS-232, 8 programmable LEDs, 8 switches, and then there's a power connector and then an onboard voltage regulator. The IDE is based on Eclipse. It uses the GNU toolchain for cross-compilation and debugging. The provided real-time operating system is MicroCOS. The standard C libraries are the open source Cygnus support and math libraries, and then there are a bunch of other libraries that are provided for simplifying programming with the NetBurner. So by default, all software is installed to an nburn subdirectory under the root directory, and then so if you open up a file explorer, go to the root directory of your C drive is where I installed it. Then there's an nburn directory. Then there's a bunch of subdirectories under there. You see the NB Eclipse contains the NetBurner version of Eclipse, so you could just double click on the nbeclipse.exe to start up NB Eclipse, but I think most of you are probably starting it up from the start menu, going back up to the nburn directory. The GCC M68K directory contains all of the cross-compilation tools and libraries. In particular, in the bin directory, you'll see the MC68K ELF GCC version that will be used, or G++ version that we'll be using for compiling our various applications. The lib directory contains the microcos, so going back up to, contains the microcos operating system library, as well as all the additional NetBurner supplied libraries. Of course, in the include directory contains the header files. The system directory contains all of the source code to the operating system and the NetBurner NetBurner libraries. The PC bin directory contains the tools that we'll be using, in particular the MTTY serial communication program is located in that directory. So PC bin, you see the mtty.exe. A few other programs we'll be using a little later in the course here. And the PC tools contains all the source code to those tools. There's an examples directory that contains the source code to several examples. Probably the most important one to us at this point is the docs directory that contains all of the information, the programming information about the operating system, and then the additional libraries provided by for the NetBurner. So under the docs directory, nburn docs, the NetBurner runtime library. Again, the microcos library is available here in PDF format, and so again, you may be able to guess at what a lot of these functions do: a task create, task delete, time delay, semaphore init, post pen. We've got mailboxes, queues, FIFOs. So a lot of things that we've looked at. There are flags, which if I recall are similar to events. You know, to use any one of these, for example, the OSM init, you can just click on it here and it'll jump right to the documentation for OSM init, where we've got the prototype for the arguments as well as the return type here. So again, you'll be using this a lot as we're programming with the NetBurner. And then the NetBurner runtime libraries is the other one, and 420 pages here. I think we've already looked at this briefly last time. A lot of documentation on various networking libraries, FTP server and client libraries, HTTP and HTML libraries. So you can actually run a web server library on doing I/O, I2C. POP3 is a mail client library. You can also run a mail server on this thing. Serial library here for using the serial devices. System library is what we looked at before for both the put LEDs for turning on the LED, turning on and off the LEDs on the board, and then also there's a simple routine to read the state of the DIP switches that are on the carrier board or motherboard. In other directories in the nburn GNU directory, you'll find documentation for all the standard C library as well as all the math library functions. And typically, you would start with the in the docs, the documentation overview, and read that first. And then look at the NB Eclipse Getting Started Guide, which is in the Eclipse directory. But those documents primarily assume that you're going to download applications over the Ethernet link. We will be doing that eventually, but I'm actually starting by having you download applications over the serial link. I'm not trying to be mean. You'll see that when we start downloading things over the Ethernet link, the transfers will take place a lot more quickly, but there's some advantages to learning how to use the serial link, in particular for debugging. And then also, if your program crashes, you can't actually transfer files over the Ethernet link, and you have to fall back on transferring your applications over the serial link. So it's important to know how to use the serial link. Again, just initially, and then as we get into some networking with the NetBurner board, I promise we'll switch over to the Ethernet link. Some other documentation. There's some documentation on the processor itself, and on the hardware motherboard, as well as the carrier board for the processor. And then there's a complete programmer's reference manual. It's over 600 pages on the Coldfire programmer's reference manual. There's even a manual that describes the various tools for like MTTY and stuff like that are briefly described in this NetBurner PC tools. And then finally, you can get a lot more information on the NetBurner website. Okay, so here's the program I had you download last time, or something very close to this. I've left off the include files here. Again, our initial task routine is user main instead of init, like it was for RTEMS. It's user main for microCOS. And then you might guess this OS change priority changes the priority of this routine. We'll talk about this main priority as a macro. Uses iprintf. It's a smaller version of printf. It's great for printing strings and integers, but you can't use it for printing floating point numbers. But if your application is not using floating point numbers, iprintf can make your application a lot smaller. And here's our forever loop that just prints out hello there, and then advances this counter, and then there's a time delay of 20 ticks. So all of this should be pretty familiar to you based on what we've done before. Again, here's I think I went over all of this discussing the previous slide. We're going to be using NB Eclipse. We've done all of this. I just wanted to document it here so that you would have it to refer to. The steps for. I've already been contacted by a couple students who have forgotten what we did in class to transfer applications over. So we can launch NB Eclipse from the Start menu. The first time you start, you'll be prompted for a workspace. It says here I suggest you use nburn directory on a network drive. That's for working on the computers in the lab. Just saving them to a network drive would give you access from anywhere. But if you're working on your own PC, it's probably you want to save somewhere under your home directory probably. And you can switch workspaces using the file menu. And then we went through this process to create a new project, select new project, and then in the wizard that appears, select NetBurner project, type in a project name. That will create a new directory under the workspace. Keep that in mind because that's where your application will be. In particular, the compiled application that you need to transfer over to the board. So when you transfer over, you'll have to get into the right directory every time. The next window will allow you to build both the release and debug versions. The final window has you select the target platform. I think most of you are going to have mod 5270s. A few of you may have the mod 5270B version. So select the mod 5270B if that's what you have, and then click Finish. Okay. All source files in the project directory are automatically compiled and linked into the application when the project is built. So you don't have to actually add files into the project. If they're in the directory, they'll be compiled and linked into the project. Occasionally you do need to refresh the project after copying files. So I had that other video that I sent out that went through all of these steps and showed you how to do that. So look at that video also if you have any questions. You can right click on the project folder and import a file into the project. That will copy a file into the project directory. Again, I went through that process in the video as well. Initially, when you first install the MB Eclipse, the project will be rebuilt whenever you save projects changes to a project file. I don't particularly like that feature. You can disable that from the project. Let me switch over to Eclipse here. So you can turn that on and off by selecting this build automatically. Again, to each his own. So after building the project, the binary executable can be found in the release subdirectory. It will have an ELF extension. The monitor program on the target requires that the executable be converted to Motorola S-Record format. This is a text format. This is automatically done when you build the project. You'll find files with .s19 and underscore app.s19 extensions. So here under the release directory, you'll see underscore app S19 and S19. Right now, you'll want to transfer the app S19 version of the file over. So you'll notice here I've got the 3 project directories we had last time. So make sure that you grab the right app S19 file from from the correct project directory. This is, when I copied the file over, the source code file, I changed the name of the file. I'd recommend that to make sure that you actually get the right version of the file. Let's see. You can download the S19 file directly into SD-RAM, but you typically don't want to do that because that's lost when power is removed from the target. The app S19 is a compressed version of that. That's downloaded to flash memory, and then the monitor automatically decompresses that whenever you reset or supply power to the development kit. Connect the power and serial cables. Connect the serial cable to the UART 0, which is the middle connector just next to the power connector. Start the MTTY utility. Set the appropriate port number. So I don't know what that is on your computer. It will vary. If you're connecting directly to a hardware serial port on your PC, it is probably COM1. If you're using the USB adapter, it will most likely be either COM3 or COM4. Again, in the video, I gave you some tips on how to find the appropriate COM port. Press the reset button on the board, and then make sure that the MTTY window is selected so that you click in that window, press the reset button on the board, and then you've got 2 seconds to press a capital A on the keyboard. And don't freak out if you don't get there in 2 seconds. Just reset the board again, and then type capital A. It takes a little getting used to, but you'll master it. When you see the NetBurner prompt, you can type help there. And right now, what we'll primarily be typing is FLA to flash or download an application. So you have to type FLA and then enter, okay? And so I'll go through that process. Let's see. Let me bring up, you can actually start MTTY here. You can actually start it on another monitor, so that looks like this. On my board, Actually, COM3 is the only one showing, but it's because I don't have my board powered up. So let me supply power and plug in the USB adapter. Let me restart. Yeah, so now COM4 is appearing, and then connect. The board is already running a program, but here I've clicked in the window. I'll reset my board by pressing the blue button. I've got 2 seconds to press Shift A, then FLA, excuse me, enter, and then up at the transform menu, send a text file, send file text, or just press F5. And then now I have to navigate over to my NB Eclipse, get the right folder directory, the right folder, go into that, into the release, read switches app S19, and then it'll start the transfer. Okay. Then when it completes, you should get a message that indicates that the file has transferred successfully. If you don't see that, then we got record end detected here, and then the program actually restarts. Okay. So after the download is complete, it'll start automatically. Pressing reset or removing power should also start the application. You can also start an application loaded from into Flash from the monitor prompt by typing boot. Again, we won't actually be using that method at this point. Okay. MTTY is just a serial terminal software that comes with NB Eclipse. You can use PuTTY or TerraTerm to actually connect to the board if you want to over the serial connector. TerraTerm even has a menu that would allow you to download files just like MTTY. MTTY is when it's installed when you install the NB Eclipse, so it's what I'll be working with. You can avoid the whole NB Eclipse and use makefiles instead, but that requires setting up a number of environment variables correctly, so I'm going to recommend using NB Eclipse. My lecture here says bring the board, serial power, and red network cables to class each time. Please return everything at the end of the course. Of course, you won't be bringing this material to class. So that's it for the lecture. Let's see, I'm going at over 20 some odd minutes now. So I'll send out an email about how to get to this lecture, and then send out information about the Zoom meeting tomorrow morning at 10 a.m. No additional exercise today. The Zoom meeting will just be to ensure that you've connected the board and you're able to transfer applications. Want to make sure everyone has everything up and running, because you will get your next assignment on Tuesday, and I want everything up and running by today, by Thursday. So we'll try to iron out any problems you may be having in the Zoom meeting. I'd like for everyone to attend the Zoom meeting tomorrow in case you have any questions about the course format or anything. We'll try to answer those, maybe get help from others in the meeting as well. Never used Zoom before, so we'll see how it goes. I will talk to you tomorrow morning.